Hi, everybody. My name is Prasad. I would like to introduce three things here. One is the namespace isolation. Next is the network policy and the virtual network topology. So as Michael mentioned earlier, when we create a cluster, typically we have a pod network and service network. So we are calling that as a default pod network and default service network. So all default pod network on the regular namespaces, when the pod is created, will be working with this default pod network. And the same thing, if when we create a service, it's going to use the default service network. So as Larry and others were asking earlier, when we have the network, these networks are nothing but virtual networks, which are based on the BGP. And each of these virtual network would have a route target. When we create a virtual network, what we do is we have an export route target, let's say RT1, and the import route target RT1. So what that means is when we are exchanging the routes for a given virtual network, we will export with that route target. And same thing when we import it, we import with that route target. So now if you see here, we also can create additional virtual networks. And these virtual networks are not typically connected until we use other constructs to connect them using import-export route targets. So I will also demonstrate how we are going to control this connectivity between virtual networks. So now, given this namespace and the basic pod networking virtual networks, I wanted to introduce this isolated namespace. Isolated namespace means we are trying to isolate that namespace, the pod network connectivity, service network, and the any other virtual networks. So that means it's all internal, and it can go outside world towards to the internet, but it won't be interacting with the other isolated namespaces. You could do this with the network policies, but it's going to be pretty cumbersome to do with that. So let me go back to a demo on that. So here I'm creating a regular namespaces called NS1 and NS2. It looks like I already created them. And so then I'm creating two parts on that those isolated those namespaces. After that, I'm creating isolated namespaces and creating two parts. So as you can see here, I have two parts, which are pod 1 and pod 2, which are in NS1 and NS2 namespaces. And the other parts, which are pod isolated 1, ISO 1 in isolated namespace. Isolated 2 is an isolated namespace 2. Now, if I wanted to do kubectl exec minus IT, so I wanted to communicate between test pod 1, which is in the regular isolated namespace, into the other pod, which is in the other namespace. So I would be able to communicate, or vice versa. So whereas if I go to the isolated namespace pods, which is, so I'm pinging from isolated namespace 1 to isolated namespace 2. And the ping won't go through because they are in two different networks. And until they are connected, the communication won't happen. So this is the isolated namespace concept. And the next one I wanted to demonstrate is the network regular network policies. So as you see here, I'm creating three different tiers. web tier, app tier, and DB tier. My network policies, this is a regular Kubernetes network policies to show that we work in the application based firewalling. So here I have three network policies. One is connecting between web to app and app to DB. So because of this, I should have only communication between app to app and app to DB, but not from web to DB. And if I don't have these network policies, I would be able to communicate freely because there are no network policies. So let me show that. So here, as you see here, I have network policies, which are three network policies: web tier, app tier, and DB tier. And also, there are three pods running in the same default namespace. So I'm going to take from pod 1 and try to communicate with pod 2, which is the app, web to app. And so now I will try to communicate to the DB, which is, it should not happen because, we have the network policies which are preventing the traffic. And whereas if I go to pod, which is the web pod, app pod, then I should be able to reach to the DB. And if I remove the network policies, and I should be able to do the communication between, any to any. Hence, I have the communication path. So this is a regular network policies. I just wanted to demonstrate that.
Sorry, Prasad, if you don't mind real quick, I think on that network policies, what's really interesting there is also the way that we implement that, right, is based upon some of those tags. So you're not having to go through and define by IP address, right? It's really based upon the tags to define that policy. And it layers in nicely too with the namespace isolation that Prasad kind of walked through initially. You may ask yourself kind of like, well, Kubernetes provides namespace isolation, right? Like what's different here? And really what's different is that it's not done at a networking layer. It's up to the CNI to do that. So Contrail is a CNI. We're providing that segmentation for namespace isolation down to the networking layer. So that's going to help prevent things like lateral attacks, some of those types of scenarios. If one of your isolated pods, for example, did get compromised when you have namespace isolation all the way down on the network layer.
That's correct. So, and just to add on top of what Sean mentioned is, so the vRouter, when it implements, we use the tag-based, comparisons instead of IP addresses. And also what that means is these tags are exchanged through the BGP. So for example, let's say I bring up a pod called web pod, and which is tagged with, tier equal to web. And when we are exchanging this route for this particular, pod tagged with web, in addition to sending the route, we also send the tags along with it in the BGP. So that makes it, pretty scalable, and it reaches to all the other, vRouters. And all we are going to do is we are going to use the tag ID to do our comparisons. So it becomes, pretty efficient, and pretty scalable at the, vRouter data path layer. So we don't have to have the indirections, like IP tables or any other things.
Yeah, that's a great point too, Prasad, because we just, you just declare that through the YAML files. So we go ahead and conceal the complexity under the hood of handling that between BGP. So yeah, great point.
Sure. So the other area I wanted to introduce is the virtual network topology or the virtual network routing. So as Michael demonstrated, we have multiple clusters, a virtual network, which is a default pod network in cluster 1, and you have another default pod network in cluster 2. So right now, to communicate among those, we have constructs called a mesh network. If we want, we can create a mesh network between clusters. Or this doesn't have to be across clusters. This could be inside a cluster. And same thing, we have another construct where hub and spoke relation between the virtual networks. So what it gives you is the very additional flexibility for the consumer to do how these networks can be stitched together. If we don't have this construct, if everything is a flat network, it may not be advisable for certain, use cases. So that's where, we have virtual networks using the BGP, and, we stitch them as needed, basically. So one is the, mesh construct, other is the hub and spoke. So the big difference is when we have the, mesh, everything is communicating to each other. And when we have a hub and spoke, hub and spokes can communicate each other, but not spokes, basically. All this is done through the simple concepts using the RT import and exports, basically, in a given virtual network. And everything is taken care by the BGP constructs in the backend.
Yeah, I think if I could add on to that too, Prasad, the nice part here, right? Think about your hub being some common services that you want to be able to support to these different spoke virtual networks. But really the key takeaway here is that the hub is non-transitive, right? So you still have segmentation and isolation down to your spoke virtual networks. However, you can also, you don't have to replicate services within each one of those, right? You can basically tie in some services into your hub that need to support the various different spokes. So it gives you that layer of isolation, again, down to the network level, and that can be applied across, multiple different environments, whether that's, on premises, cloud, what have you, all with Contrail.
So let me demonstrate that. So I have a namespace called a test NS. And in here, I have created two labels for each virtual network. One label is to create a VNR1 mesh. Other label is VNR2 with a hub and spoke. So first, let me create a mesh network and try to ping each other. So before that, let me show the pods which are in these three networks. And kubectl get VNR and test NS. So I don't have any VNRs created here. So what that means is, as you see here, test pod 2 belongs to VN2, 3 belongs to VN3, and 4 belongs to VN4. If I try to communicate among those, it won't work because they're all isolated virtual networks. Actually, let me have.
While you're doing that, Prasad, too, I think the nice part about this is that default behavior of having that isolation between your virtual networks. It's a little bit of a different method when you're turning around and deploying these networks for your Kubernetes environment with Contrail, right? It just gives you by default, each one of those are going to provide this level of isolation from a virtual network perspective, and then you can declare where you want connectivity easily as deems and kind of fits your organizational policy. You may have different applications for different use cases. Some things may be internal, other things may be like external facing applications as well.
I have a question regarding the assignment of virtual networks and what the boundaries are. If you want to assign something to a virtual network, is that done at the namespace level or is that done at the pod level? And can these virtual networks, I guess they can span clusters. Am I also understanding that correctly?
Yeah, so basically when you create virtual networks, it is, under the namespace you can create, or you can create at the higher level, at the cluster level. So if you see into the beginning, we have a default pod network, so which spans across multiple namespaces. And whereas you can create a virtual network inside a namespace, as we are showing it here. And the other construct which you're asking is among clusters. If it is a Kubernetes, if it is a CN2 cluster, we can create across the clusters. But if you have multiple CN2 different clusters, as Michael shown, then we use the connectivity between these networks cluster one to the other cluster using the one of the constructs which we are going to use, either mesh network or the hub and spoke.
Just to conclude on that, yes, we definitely can span a virtual network across clusters. It basically means what do you mean by spanning? So we can create one layer 2 domain across multiple clusters, serving the same IP address of the same subnet across clusters. The only thing you need to do is, because the IP address assignment is not going to be synchronized, but what we support is in the subnet, we can define a range out of which we will assign IP addresses to the pods. So basically you can say, on my first cluster, I'm going to use .1 to 100. On my second cluster, I'm using 101 to 200. On my third cluster, I'm using 201 to 255 or 254, depending on your subnet size. But the workloads themselves, they will think they are in one huge layer 2 domain. So they can communicate using normal layer 2 lookups.
That is true. Or if you choose to have each cluster has its own default virtual network and connect them also, we can connect.
Okay, and any pod that gets created in a namespace that has a virtual network will automatically be part of that virtual network, or is that something you have to assign at the pod level?
You have to assign that at the pod level. So per default, the pod is created in the default pod network. If that pod is part of a isolated namespace, it is going to be created in the isolated namespace default pod network, which is different from the normal default pod network. But if you want then to even connect that pod to a non-default pod network, so let's say you want a secondary interface on your pod, or third interface or fourth interface, you have to configure that on the pod level. So you need to tell the pod as part of the annotation, using the network plumbing working group style, connect me a second interface or third interface to a given virtual network. Yeah.
And just to add at the distinction between pod network assignment at a pod level or a namespace level, sorry, that makes sense when you're isolating a set of workloads. So basically, I want this whole set of workloads to have their own virtual network and to be kind of jailed off from the rest of the pods. But from the pod's perspective, it has a normal pod network connection. It has a normal service network connection. It just has its own little copy of it. And then for multi-interface workloads, or whenever you're creating these arbitrary virtual networks, you want that to be on an interface by interface basis, because you'll have like a network for, say, inbound internet traffic and a network for, outbound services traffic or something. You're basically recreating a multi-interface server using these network attachment definitions.
Within each cluster, you've got a virtual router that's handling communication between the virtual networks. Is that also part of the architecture?
Yeah, Contrail actually has a distributed virtual router, so the routing takes place on every node in the cluster. So the concept of the router is logical. It's everywhere in the cluster. Right.
So it's running as like a daemon set on each node in the cluster. Okay.
Yeah, that's
a daemon set. Yes.
Yeah.
And is there an opportunity to insert firewalling and rules of communication between subnets?
Yeah, there's a couple ways that we do that. Network policy is the way that we create firewall filters inside Kubernetes to filter out traffic. And you saw a little bit of that during Prasad's demo. And then also we have another construct that allows you to create very flexible import and export policies on a per prefix basis between all of the virtual networks. So you've got a big stick and then you've got the scalpel as well.
Okay, thank you.
Oh, thank you.
Okay, so here in this use case, we have created 3 pods. And as you see here, there are 2 interfaces for this pod. One is in the default pod network, other is in the test VN2, test VN3, and test VN4. So right now, what we have done is, if I try to ping between the secondary interface, which is the test VN2, 3, and 4, that communication won't happen because there is no virtual network router which is connecting them. So that what I'm trying to do the ping test between test pod VN2 to VN3 or VN4. So I'm going to create a mesh network. Control create -f test VNR mesh. So now the same ping test would go through because we have created a mesh network. What that means is each virtual network is going to do the import and export route targets to the same route target so that the mesh communication happens. And so I would like to demonstrate the other option, which is the hub and spoke. So with this, what we have done is, we have one hub and, two spokes, which is VN2 is the hub and, VN3 and 4 are spokes. Now I'm going to do another ping test. So in this here, we are doing, hub to spoke communication. Then after that, we are trying to do a spoke to spoke communication, which should not happen because that's what is the intended here. So all we are doing here is we have virtual networks using the route targets to manipulate the way we want, whether we wanted to have one direction communication or bidirectional communication or having a communication among all the virtual networks. So now so far what we have shown is how to isolate a namespace, then regular Kubernetes network policies. And the third is how do we connect the virtual networks so that we can communicate each other at the network level. And also another key takeaway is in the network policies, the way our implementation is we use the tag-based implementation at the vRouter level so that it's pretty fast and also we use the BGP to exchange these tags.